Let's do a practice problem. The waiting time for customers in a queue at a bank is not the same for all customers. Suppose that the waiting time is normally distributed with an average of 6 minutes and a standard deviation of 2 minutes. What is the probability that a customer has to wait more than 10 minutes? So this here we have, suppose that X is the random variable that stands for the waiting time of customers at a bank. And that says it follows a normal distribution with an average of 6 minutes and a standard deviation of 2 minutes. So always the first value is the mu here, and the second value is always the standard deviation. All right. The question asks for the probability that a customer has to wait more than 10 minutes. So this is how we formulate this problem. You need to find the probability that X is greater than 10. So please pause, work on this problem, try to solve it, and then after you try and solve it, then come back to see the solution. All right, let's see the solution. So here we have the probability that X is greater than 10. What we need to do is to convert this to a z distribution. So let's see actually how the graph would look like. So this is this normal distribution, and what we are looking for the probability that X is greater than 10, which means that the shaded area, the red shaded area here, so this would be the area here, that would be our probability. So we have to find that. So what we can do is here we can convert this to a z distribution. So this would be equal to the probability that z would be greater than z score of 10. Z score of 10. Let's see what is z score of 10. Z score of 10 is 10 minus the average, which is 6 here, divided by standard deviation, which is 2. And that's equal to 10 minus 6 is 4, divided by 2, that's equal to 2. So the z score is 2, z score of 10. So we have to find the probability that z is greater than 2. But there is a problem here, because if you take a look at the z distribution table, the z table here, as you see here, it is for the values less than z, not greater than z. So it always finds the shaded area on the left side of a value, not for the right side. So what can we do here? Well, what we can do here is actually to use the probability of the complement of an event. We know that the probability of the whole sample space would be 1, right? That means that for normal distribution, the probability that X is from negative infinity to positive infinity is equal to 1. That includes the whole shaded area of this graph, if the whole area is equal to 1, okay? Now, so we are looking for the z greater than 2. If the table gives us the left side here, this side here, that means that 1 minus this value would be the, so this is the probability that what tables gives us is the probability that z is less than a small z value. This is the shaded area here that the table gives us. So this means that the unshaded area, which is in white here, this area, is actually equal to the probability that z is greater than a small z. So what we can do is we can say this is actually equal to 1 minus the probability that z is less than or equal to the small z. because if the whole area here is equal to 1, and this shaded area here, a small one, is the probability that z is less than z, then this white area here would be the probability that z is greater than z, which is 1 minus the probability that z is less than z. So we can write this as the probability, as actually 1 minus the probability that z is less than or equal to 2. So now we can look at the table and find this probability. The probability that z is less than 2, if you look at the table, is 0.9772. So this is 0.9772. Then 1 minus this probability would be equal to 0.0228, which if we actually round it up, is going to be 0.023. So it's 0.023. That's the probability that x is greater than 10. We could also use Excel to do that, but still we have to convert it to less than 2. So whenever you have a probability that is greater than 2, to be able to solve it either using Excel or using a z-table, you have to convert it to the less than 2 to be able to solve it. And even if you use the Excel, you're going to get the same value. That's 0.023. Next practice problem. The demand for newspapers each morning at the newsstand is normally distributed with a mean of 85 newspapers and a standard deviation of 20 newspapers. What is the probability that the newspapers will sell 105 copies or more? So please pause, work on this problem, think about it and try to solve it, and then come back to see the solution. All right, let's see the solution. So here we have a random variable that actually is not continuous, right? The number of newspapers, if x stands for number of newspapers, x is not continuous. We cannot have 100.6532, right? We cannot have non-integer numbers, okay? Because it's a number of newspapers. We cannot have 5.2 newspapers. So, but we can use actually the normal distribution to solve this, because we have actually big numbers here, large numbers, 105 copies, the average is 85. So that's why we can actually approximate this probability using the normal distribution. So let's solve this problem. So x is the number of newspapers demand, and it says it follows a normal distribution with an average of 85 and a standard deviation of 20. So what we are looking for is to find the probability that the newspaper would sell more than 105 copies. This means that the demand is more than 105 copies. So we need to solve this problem to find the probability that x is greater than 105. So what we can do is we can use the same method. We can convert this to a z-distribution and then find the probability. So let's do that. So this is equal to the probability that z is greater than the z-score of 105. Let's see what is the z-score of 105. Is 105 minus the average, which is 85 here. 85 divided by standard deviation, which is 20. And that's equal to 105 minus 85. That's 20 divided by 20. 20 divided by 20. That's equal to 1. So this would be equal to the probability that z is greater than 1. And again, this is, if you want to use the z-table, we have to use 1 minus this. We have to convert this to less than probability. And how we can do that is we have to convert this to 1 minus probability that z is less than equal to 1. This z is less than equal to 1. This is complement of z greater than 1. And we know that a general formula is the probability of A is equal to 1 minus the probability of A complement. So this is A complement here, if this is A. The probability that z is less than 1, we find that from the table, and then we subtract it from 1. We can also use the normal.dist from the Excel to do that, and we get the probability is equal to 0.16. So we find this probability from the z table, and then we subtract it from 1, and we get 0.16. So the probability that the newspaper will sell more than 105 copies is 16%. Next practice problem. We have obtained the data for customer satisfaction scores of last year and see that it is normally distributed with average mu equal to 72 and sigma equal to 12. What is the probability of getting a satisfaction score lower than 84? So please pause, work on this problem, try to first formulate the problem, what exactly the question is asking for, and then try to solve it, and then come back to see the solution. All right, let's see the solution. So here we define random variable x as a satisfaction score that we get from customers. So it says that the question says that this follows a normal distribution with an average of 72 and a standard deviation of 12. What the question asks for is finding the probability at x is less than 84. We want to find this probability. So what we can do is we can just convert this to a z distribution and then solve this problem. So let's do that. So that would be equal to the probability that z is less than the z score of 84. So let's find the z score of 84. That's equal to 84 minus the average, which is 72, divided by a standard deviation, which is 12. And that's equal to 84 minus 72, that's 12, divided by 12. And that would be 1. So this is probability that z is less than 1. And then we look at the table and we find that probability, and that would be our answer, which is about 0.84. So here, if you notice, we don't have greater than, we just have less than. So when it's less than, we can directly use the z distribution, and we don't have to use 1 minus. Okay, so when it's less than, do not use 1 minus. When it's greater than, use 1 minus. Next practice problem. We have obtained the data for customer satisfaction scores of last year and see that it is normally distributed with an average of 72 and a standard deviation of 12. If 500 customers are surveyed, how many customers on average would give us a satisfaction score more than 78? Please pause, work on this problem, and then come back to see the solution. I should warn you that this is a little bit tricky and challenging question. All right, let's see the solution. So for any customers, there are only two possibilities. Whether the customer would give us a satisfaction score greater than 78 or would give us a satisfaction score less than or equal to 78. So there are only these two possibilities, but we are interested in the first one. So I'm going to call that one a success. So the next one would be called the failure. We have 500 customers, and for each customer there are only these two possibilities, a success or a failure. This looks like we are repeating this story of success and failure 500 times. Do you remember any distribution that would suit this situation? Like the number of customers that would give us success, or the number of successes in a repeated experiment? If I define Y as the number of customers that would give us a satisfaction score greater than 78, what do you think the distribution Y is? And consider that there is only two possibilities for each experiment or for each customer. So actually Y would have a binomial distribution. N here, binomial distribution has two parameters, N and P. N here is the number of customers that we have, which is 500. And P is the probability of success. C is the probability that this happens. So what we need to do is to find the probability that we get a satisfaction score greater than 78. Probability of satisfaction score greater than 78. This is our P here. Okay. But the problem says that the satisfaction score for customers actually follows a normal distribution. So if I define X as a random variable representing the satisfaction score for customers, according to the problem, it follows a normal distribution with an average of 72 and a standard deviation of 12. Okay. So what we are looking for is the probability that X is greater than 78, which is a normal distribution. So let's find this probability, the probability that X is less than 78. After we find that probability, I'm going to call that probability P, which is here. Then we can actually find our solution to the problem. The problem is asking for the average number of success, right? The average number of customers who would give us a satisfaction score greater than 78, which is the average of random variable Y, which is another term for the expected value of Y. Y is a binomial distribution, and the average of, or the expected value of binomial distribution is N multiplied by P. So after we find P, N is 500, we multiply 500 by P and we get the average number of customers that would give us a satisfaction score greater than 78. So let's find 78. Let's find the probability that X is greater than 78. All right, so we are looking for the probability that X is greater than 78. If we look at the normal distribution here, the probability that we are looking for is actually the red shaded area here, the probability that X is greater than 78. How we can solve this? Well, that's not difficult. So we have learned that we have to convert this to the Z distribution. If you want to find this using the Z table, we're going to convert this to the Z distribution. Or we can use a software or a calculator to do this. That's the advanced calculus. Okay. So now we assume that we want to use a Z distribution table. So this is equal to the probability that Z is greater than the Z score of 78. So let's find the Z score of 78. The Z score of 78 is equal to 78 minus the average, which is 72, divided by standard deviation, which is 12. And these two comes from here, and here. If you compute this, that's equal to 78 minus 72, that's 6 divided by 12, that's 0.5. So what we are looking for is the probability that z is greater than 0.5. But what you have to remember is the z distribution always give you the probability that z is less than something. For example, z is less than z star, okay? But here we are looking for a probability that z is greater than 0.5. So what we can do is we can actually do the complement of this, 1 minus the probability that z is less than 0.5. So this part is actually doable using the z distribution table. You may wonder why these things work. Well, this is actually based on what we have covered very early on in the course, and that's the probability of A complement is equal to 1 minus the probability of A. If you consider the probability that z is less than 0.5 as A, this is A, then what we are looking for is the probability of A complement. So that would be 1 minus the probability of A. This is why we can do this. We use the complement probability. So we find the probability equal to 0.31. So the probability that we get a satisfaction score more than 78, or we get actually the probability of success, is equal to 0.31. So this is the probability of success. So now what we need to do is we need to go back to our binomial distribution. The number of customers would follow a binomial distribution with n equal to 500 and probability of success equal to 0.31. So the expected value, or the average number of customers who would give us a satisfaction score greater than 78 is actually the expected value of y, which is n multiplied by p. This is n is 500, and p is 0.31, and that's equal to 155. If you get a value that is not it has to be a complement number, a complete number. It has to be an integer number. So you might have to round it up or down to get to the value. So on average, we would expect to have 155 customers to give us a satisfaction score more than 78. As you see here, this was a little bit tricky question. So make sure that you understand this, how to solve and approach such a problem for future, or probably for the exam.